Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to take a look at wireless networking. I'll explain the wireless networking standards, describe the processes for implementing Wi-Fi networks, and describe troubleshooting techniques for those Wi-Fi networks. So to understand wireless networking, we have to understand the basics. It all starts with frequency, radio frequency. All wireless networks use radio frequency waves as their media. They are extremely convenient, and in some locations, they are the only option. Some wired networks just can't go where we want connectivity to reside. They do use the same OSI layers as wired networks. They use the same upper layer protocols as wired networks. However, they do use different methods for accessing the media. All Wi-Fi is based on the IEEE 802.11 Wireless Ethernet standard. So let's talk a little bit about these standards. The Wi-Fi 802.11 standard is broken into substandards: 802.11a, .11b, .11g, and .11n. They're certified by a 300-member Wi-Fi alliance. Devices that carry this certification should ensure that they're compatible with each other. The 802.11 standard itself defines how devices will communicate, some of how they will secure those communications, and each substandard has an IEEE subcommittee. So let's start with the hardware. You're going to need an adapter. This is your wireless NIC, whether it be a PCI or PCIe card, maybe a PC card, or an external USB. You're also going to need a WAP, or a wireless access point. Understand that a basic WAP is a layer 1 hub. What you have in your homes, well, it's really multiple devices in a single box. You have the high-speed hub or switch. You also have a bridge, and you also have a router. Next, we need software. This is the wireless device drivers themselves, wireless configuration utilities, as well as utilities to manage the strength and other settings such as security and power saving options. When setting up wireless networks, we have choices, beginning with ad hoc mode. This is a peer-to-peer mode. It uses a mesh topology, and you'll see it in the setup utility indicated as Independent Basic Service Set, or IBSS. The next mode you'll have is infrastructure mode. Within infrastructure mode, you have two additional choices: either the basic service set or the extended service set. With the basic service set, you're going to service multiple computers with a single WAP. With an extended service set, you'll be servicing those endpoints with multiple wireless access points. When it comes to range and wireless, at best it's a little fuzzy. It's kind of hard to define. The 802.11 standard indicates that your wireless signal should be approximately 150 feet. However, there are several environmental variables that can alter that maximum standard. So let's talk about some of these service sets, if you will. Starting with the basic Service Set Identifier. It is the most basic of the infrastructure modes. BSS, remember, is one WAP for multiple computers. The BSSID is the MAC address of the WAP itself. When operating in IBSS mode, The nodes and ad hoc modes use a 48-bit string. So the service set identifier itself is nothing more than the network name. It's just a standardized name that has been applied to all different types of modes, whether it be BSS or IBSS. Again, with the extended service set identifier, you're going to deal with multiple WAPs, multiple wireless access points, servicing multiple clients. Most Wi-Fi devices still use the term SSID regardless of the mode that they operate in. Next, we'll talk about broadcasting, specifically frequency broadcasting. The 802.11 standard uses the 2.4 gigahertz frequency band. Within that band, there are multiple broadcast methods. The original 802.11 standard used spread spectrum radio waves. This breaks broadcast data up into small discrete chunks and then uses different frequencies within the range. Well, with the advancement of technology, now we have 3 different spread spectrum broadcasting methods, starting with OFDM, the orthogonal frequency division multiplexing, the FHSS, frequency hopping spread spectrum, and DSSS, direct sequence spread spectrum. So let's take a look at each one of these. With DSSS, direct sequence spread spectrum, it sends simultaneously on different channels. It uses a pretty high amount of bandwidth, about 22 megahertz. It is capable of much greater throughput than OFDM. However, it is more prone to interference than FHSS. With frequency hopping spread spectrum, the hops are from frequency to frequency. It sends on one frequency at a time, so the result is much lower bandwidth utilization, about 1 megahertz. And orthogonal frequency division multiplexing, OFDM. This is considered the modern method of the 802.11 standard. It combines multiple frequencies of DSSS with the hopping capability of FHSS. So now that we understand broadcasting, you need to know where to tune into. Well, these are the channels within the broadcast spectrum. The 802.11 standard is defined with 14 individual channels. However, in the United States, generally you're only going to see 1 through 11 used. And to further confuse things, most WAPs are going to default to only using channel 1, 6, or 11. Next, you need to understand how your data is going to travel on these channels. It uses CSMA CA. Now, this should look familiar to you from the wired networks, which use CSMA CD. So what's the difference? The difference is detection versus avoidance. Wired networks use collision detection, where wireless networks use collision avoidance. Because wireless devices can't detect collisions on the line because there is no line. It's air, it's space. So there are 2 collision avoidance methods: distributed coordination function and point coordination function. The Network Plus examination expects you to know and understand the different wireless standards, the frequency band that they operate on, and their maximum data rates. So no discussion about wireless would be complete without discussing security. The primary issue that we have with wireless is that it is extremely easy to install, and most devices have little or no default security along with them. And since what we're really talking about is securing space or securing air, it can be extremely difficult to secure the radio waves themselves. We have three basic methods to attempt to solve this problem: either MAC address filtering, wireless authentication, or data encryption. First, we'll start with Wireless Protected Setup, or WPS. This is an industry standard which is extremely user-friendly, and it allows for either push-button or pin authentication. For push-button mode, you'll push a physical button on the wireless access point itself, and then on whichever device that you're attempting to authenticate with, you'll push a software button, and the two devices will auto-configure from there. Additionally, you have the option of using the PIN method. It's an 8-digit number that you'll use for wireless authentication. However, the issue is that 8-digit number is usually printed on the device itself. So that in itself causes ease. Ease, for purposes of this discussion, equals very poor security. Next is MAC address filtering. This limits access to the network itself by the specific NIC. Those NICs are associated with accepted users. The wireless access point will store all of these MAC addresses in a table. And if any device attempts to connect and that MAC address is not in its table, they will be rejected. Now, this does come with some administrative problems. It is considered to have a very high administrative overhead. Every time a user gets a new device, you'll need to manually update the MAC table. Also, it's not very difficult for hackers to spoof their MAC addresses and make it look to the wireless access point like an accepted user. Next, we'll talk about the different types of wireless authentication. This is simply users with proper credentials gaining access to network resources. It does require a few extra steps for wireless users, but most have gotten used to these extra steps by now. We'll discuss several of the wireless encryption standards, starting with 802.1x. This is probably the most cumbersome of the wireless authentication standards to administer, but the benefits often is considered to far outweigh the inconvenience. With 802.1x, you're going to need two pieces of information. With 802.1x, you're going to need two pieces. First, a radius server. That radius server is going to be using EAP, or the Extensible Authentication Protocol. That is what's going to handle your user's password encryption. The radius server is going to provide authentication for your network. It enables access to users and their rights on the network. When using 802.1x, the client computer is called the supplicant. The WAP is renamed to be the NAS, or the Network Access Server. The NAS is going to contact the radius server. The radius server will check the security database for the provided credentials, and if they match, the user will be granted access. This in itself brings a unique issue called the gap in the WAP. The initial supplicant request to the NAS is being handled via a protocol called PPP. We've discussed that earlier. So you're dealing with credentials potentially in the clear. Now, after it hits the NAS and that back-end communication from the NAS to the radius server, well, that's being handled by IPsec, so no worries there. It's the initial authentication request from the supplicant that is the gap in the WAP. One point to note is when you are setting up an 802.1x wireless infrastructure, the WAP and all wireless NICs must be using the same authentication protocol. So you need to ensure that your users know whether you've selected EAP TLS, EAP TTLS, or PEEP. Next, we'll talk about data encryption. There are 3 or 4 primary encryption standards to know when it comes to wireless networks, starting with WAP, the Wired Equivalent Privacy. It used a 64 or 128-bit encryption algorithm with a 24-bit initialization vector. The problem we ran into with WAP is it's very easily cracked because the size of the key was the core weakness. It was using either 40 or 104-bit keys, which we know today with modern computers. The work factor to break that key is relatively small. It also used a static key that was shared between all devices, and there was no user authentication. It was only the nodes by MAC address. To address some of these problems, WPA was introduced, or Wi-Fi Protected Access. It did fix some of the problems that we had with WAP. They got rid of the weak cipher algorithm and replaced it with TKIP, the Temporal Key Integrity Protocol. It used a 128-bit encryption key. However, it didn't solve the underlying problem, which was the initialization vector itself. That meant that, again, you were dealing with a small key space and the key could easily be broken. The modern standard, and what most wireless networks are set to today, is WPA2, or Wi-Fi Protected Access 2. It replaces TKIP with the very strong algorithm of AES. It's a 128-bit block cipher algorithm. And by adding a radius server for authentication, you can now enable WPA2 Enterprise. However, most home networks are going to use WPA2 with the pre-shared key. Next, we'll talk about enterprise-level wireless networks. Most of these devices are very sturdy and strong with multiple upgradable antennas. They provide for centralized management and such advanced features as VLAN pooling and personal wireless device integration. This is important if your organization is one that is considering BYOD, or bring your own device. Most of them are powered by what is identified as Power over Ethernet. Power over Ethernet allows for both power and Ethernet signals via the Ethernet ports. This is outstanding for WAPs that are often far away from a power outlet. However, to employ this, both the switch and the WAP must be Power over Ethernet capable. So understand that there are other wireless technologies, however, they don't fit in the 802.11 base network standard. These technologies include Bluetooth, near-field communication, and infrared. These are considered PANs, or personal area networks. They have a maximum range of 100 meters or as short as 5 centimeters. All of these are point-to-point technologies. They are not capable of serving a one-to-many capability. Next, let's take a look at how we will implement Wi-Fi. First, and probably most important, is to perform a site survey. This is where you will start asking the beginning questions before you even install or unbox a wireless access point. You'll need to understand, for instance, what other wireless devices may already be in the space. What radio bands are they using? Are there any existing SSIDs, and what channels are they using? You'll need to identify and locate potential spots for interference. And you'll absolutely need to create a sketch where those interference spots or interference sources are clearly identified so you can begin to plan around them. You may need, for instance, to deploy multiple WAPs into an area to avoid dead zones. Here you see a basic sketch of a site survey with the potential interference sources well documented. Next, when setting up our wireless networks, you'll need to decide what mode you will operate in. For ad hoc mode, you'll need to set the NICs to perform in ad hoc mode. You'll identify an SSID, the appropriate IP addresses, and identify the shared channel that everyone is going to use, as well as any shared resources on each computer. If, however, you're going with infrastructure mode, you'll need to identify your access point placements. And within that identification, you'll need to decide on a set of antennas. You see most of these, for instance, in ceilings and office buildings. They're using a standard straight-wired dipole antenna. Or are you going to go with an off-center position and with a focus wavelength using directional antennas? Again, these are all considerations that you must take prior to any type of access point installation. Next, when setting up in infrastructure mode, the access point needs to be configured. You'll have to configure the SSID, the beacon, and the beacon interval. You'll need to configure, if you so choose, to employ any MAC address filtering to start populating the MAC address table. You'll identify any encryption that you are going to use, whether it be WEP, WPA, or WPA2, as well as the channel and frequency that it will broadcast on. And then you'll need to configure each client to know what to listen for. And as I indicated, there are possibilities that you'll need to deploy multiple wireless access points into an area to handle interference or dead spots. So you'll need to make sure that the wireless access points that you purchase are capable of bridging, either point-to-point bridging or point-to-multi-point bridging. And then finally, after you feel the installation is complete and your job is done, you need to verify, make sure that you have proper coverage in all the potential dead spots. You should never leave a job site prior to verifying that everyone has the desired connectivity. Now, let's take a look at some basic troubleshooting with Wi-Fi. Like all troubleshooting, it starts with a cerebral exercise or a logical exercise. You need to begin not with the devices themselves, but just a logical order of questions. You need to determine the scope of the wireless problem that you're dealing with. Simple questions like who's affected? Is it just one wireless client or is it many? What's the nature of the problem? Which network services can you or can you not connect to? And when did the problem start? That'll lead you in multiple directions depending on the answers. For instance, if now you feel, based on those answers, that you're dealing with a hardware problem, you're going to start troubleshooting just like you would a PC, identifying that it has the correct drivers or that the driver is not corrupt. You can do this in Windows in the device manager. Is the device present? If the device isn't recognized, you might try unplugging and plugging it back in if it's a USB device, because they are hot swappable. Otherwise, you will need to restart the PC or laptop and see if auto detection will then find the device. However, it may be a software problem. Software problems, whether you're dealing with the wireless adapter, you're probably going to want to start looking at the configuration, making sure that the adapter is using the correct vendor's driver and the configuration utility is properly installed. Again, you'll check the device manager to uninstall and install the vendor driver and any other utility software that's required. However, with wireless access points, generally, if you feel that that is the problem, you're going to be dealing with a firmware problem. With more and more newer and newer wireless devices, it's hard for wireless access point manufacturers to keep up with some standards. They issue firmware updates often. You'll need to go out to the vendor website, download the appropriate firmware, and then reinstall.
Next, you might be dealing with connectivity issues. Connectivity issues can be kind of tricky because they can be caused by many things. Something as simple as a simple incorrect configuration to more difficult to detect, like overlapping WAP signals or what we call multipathing or signal bouncing. The solutions to these, once identified, are pretty standard. For overlapping WAPs, you will probably need to turn up the gain on an antenna. For conflicting channels, you might need to consider moving that wireless access point to a different channel, or for sources of interference, you may need to move that source of interference. Lastly, it might just be a configuration issue. You should check to make sure that your clients are connecting to the proper SSID. Make sure that the user hasn't gotten a new wireless device, that the MAC address is not in the MAC table. Or look for a security configuration mistake, like, for instance, mistyped encryption keys, or you might possibly have to look for a rogue access point.
Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry, I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.